Good morning, Hamilton County 4th graders. How are we today? Happy Monday. I was so thrilled to hear from pretty much almost everybody last week for the discussion-based assessments. Some of us did really, really good. Some of us have to go back and look at a couple of lessons. It's the most common error, though, was the area and the perimeter. So just to talk about that for a second, where'd my screen go? There it is. Okay. So if I'm talking about finding, well, we can just use a shape. If I'm talking about finding the perimeter of a shape, I am talking about going around the outside of the shape. I want to know what those lengths are. And remember, for perimeter, and P can stand for perimeter, equals length plus length plus length plus length, however many sides you had. Like if this was, say, 3, this is a square, so my sides are congruent. So each of these sides is going to be 3. So I would do 3 plus 3 plus 3 plus 3. Now some of you might be like, well, Miss Hotchkiss, that's repeated addition, and I could show that doing 3 times 4. And that's true, but why wouldn't that work for all shapes, finding the perimeter for all shapes? Well, let's look at a trapezoid. A trapezoid, not all of our lengths are going to be the same. So if I wanted to find the perimeter of this trapezoid, I'm going around the outside, the perimeter. That is the literal meaning of perimeter. I'm going around the outside of the shape, and my sides are not going to be the same. Like that one is obviously shorter than all the others. This would be more like a 3, 4, and 3. Oops. So to find the perimeter over here, we couldn't do a multiplication problem. We would have to use the perimeter formula as is using addition. So 3 plus 3 plus 2 plus 4. And that would give us a perimeter of P equals at 6, 7, 8, 9, 10, 11, 12. So for perimeter, we use addition. We add the outside lengths together. Now the opposite of perimeter would be area. Let's get our square back out here. If I wanted to find the area of this square, I am trying to find out how much space is inside this square. All up in here. Let me do that a little bit neater. Let's just color it a different color. We want everything that's in the blue. So since this is a square, my sides are congruent, this would be 4 times 4. Length times width, which is how wide it is. And you would just put your numbers in. Length, our width is 4. So our area here is going to be 16. And that's for a square. And that's really easy because we know that squares, they all have the same length. But if we were talking about a shape like, let's try the octagon. I want to find the area of the octagon, which means I want to find out all of the purple. How much purple space do I have? And in this sense, or no, we don't want to use, never mind, I take it back. We're not going to use you. You're going over there. We're going to use something a little bit easier. Let's say There we go. I like you. If I wanted to find the length times the width for this, it would be 3 times 4. You see what I mean? When you have a shape that has multiple sides, like an octagon, area is a little bit difficult. We're not going to look at that just yet. But remember, area, A for area, is length times the width. Okay? We're going to need to know that going into 5th grade. Now, going back to what we were doing last week, we were talking about angles and how to categorize them. We have obtuse angles, we have right angles, and we have acute angles. This would be an acute angle because it is less than 40 degrees. This is your 90-degree angle, your right angle. It makes a perfect L. And then anything bigger than a 90-degree angle is an obtuse angle that is bigger than 90 degrees. And then remember your benchmark angles. You have the 180-degree straight line and then the 90-degree right angle. Those are our benchmark angles. We've also been learning how to add and subtract angles. So if we had, let's make this a little bit bigger. If we had, where's my drawing tool? There she is. If we had this 90-degree angle right here, and we'll just do straight lines. Here we go. There we go. And I said all of a sudden we're going to decompose this angle into smaller angles. So we'll go here. And if we wanted to find out how much it is all together, all we need to do is say, all right, ooh, we don't want to make that bigger. Come back. All right, so this is a 25-degree angle. And then this angle right here, what would that be? How do we find that out? Let's make a, we want to know what this angle is. Well, we know we start out with a 90-degree angle. We know that one of the angles is 25 degrees. We want to know what the remaining degrees are. We would subtract. We have to borrow. 10 minus 5 is 5. And then we have 8 minus 2, which is 6. So this must be a 65-degree angle. Anywho, so that was our quick review. Day 1, we are looking at page 320 through 321 in the instructional book, page 325 through 326 in the practice book, and then we are going to work in day 17 countdown. Let's get started. So this is just the modeled and guided instruction for finding those unknown angles. Now, just like we had done in the app, we're going to use what we know about the bigger angle to try and decide how to either add or subtract in order to find out the unknown. So the problem reads, a door swings open 85 degrees and then gets stuck. Randy pushes on the door and it opens some more. Altogether, the door opens 100 degrees. How many more degrees does the door open after Randy pushes it? So the first time, let's get a couple different colors here. So the first time he opened the door, it was at 85 degrees. So this is the first attempt of opening the door, 85 degrees. Once he got the whole door open, once he gave it that last shove, we had a total of 100 degrees. Now the 100-degree angle is composed of two smaller angles. One angle is that 85 degrees, and the other angle measure is unknown. It does say that we can use a protractor to help us understand the problem. It says look at the protractor, start at 0, 0, then count up to 85, 85, bam, right there. And then how many more degrees do you need to count on to get to 100? Which would have been the big part of the angle, how far the door actually opened. Well, just like in a number line, when we're adding and subtracting whole numbers, protractors work very similar. So if this was 85, this is 5 degrees, this would be 5 degrees, and this would be 5 degrees. So it looks like 5, 10, 15 degrees is what our smaller angle is going to be. Let's take a closer look at it. Says number 8, write a sentence that describes how the unknown angle measure is related to the 85 degree and the 100 degree angle. Well, think about that unknown angle. What is the relationship there? What is the relationship between these three angles? We have three angles here. We have 1, 2, and then the big one being 3. Look at what we did on our protractor. How did we get to here? Well, we added. So from the 100 degree, it's the difference, right? That's the difference that it was from the 85 degrees to the 100 degrees. So our answer is going to say the unknown angle measure is the difference between 85 degrees and 100 degrees. Now it says, does addition or subtraction best express the relationship? Well, we already said a very big word in subtraction, the difference. When we think of the difference, we are automatically thinking about subtraction. And we already knew what our total was. We had a total of 100 degree angle. So we already knew the total. So adding wouldn't help us at all. We had to use subtraction. Hang on. All right. So number 10. Number 10 says, write an equation to describe how the unknown angle measure is related to the 85 degrees and the 100 degrees. So we said that our big angle was 100 degrees. Our little angle was the smaller angle was 85 degrees, not the smallest, because this would have been the smallest. We knew that we were going to use subtraction, so we're going to subtract. And 100 degrees minus 85 degrees is 15 degrees. Now, 11 says, how would the measure of the unknown angle change if the door opened a total of 120 degrees? So if we replace that 100 with a 120, it would look like this. It would be 120 minus 85, which would equal what? 35 degrees. Now imagine an angle that is composed of three smaller angles. If you know the measure of the composed angle, meaning the altogether angle, and the measure of two of the smaller angles, how could you find the measure of the third angle? So it might help to draw yourself a model. So if you had an angle that is composed of three smaller angles, so if I had a big angle, all right, within that angle, I had two smaller angles. So here are my two smaller angles. We have this angle, three. I thought it said 3. I was almost sure that it said 3. So we're going to split this one more time. So we have this angle, and this angle. Now, if I knew that my large angle open, let's say, at 120 degrees. I had a small angle over here that was 45 degrees. And then I had another angle over here that was 35 degrees, but this angle was unknown. How would I solve that problem? Well, just as we did up here, we're going to take that total amount and we're going to find the difference, right? So we could subtract, or you could subtract the sum of the two smaller angles from the measure of the composed angle, the large angle. Woo! Oh, there was a moth. Gosh, that scared me. Boom. Sorry if that's kind of messy. I got some rough handwriting today. I mean, my handwriting is kind of bad to start with, but today it just seems to be really bad. Alright. Hang on a second. I gotta take a drink of my tea. Alright. The try it. It says, number 13. A game includes an 8-second timer as shown at the right. So this is our 8-second timer. The timer's pointer turns through 135 degrees. So turn, there's our big turn, 135 degrees as it counts down from 8 seconds to 5 seconds. How many more degrees does the pointer have to turn through to count down to 0? Well, what kind of shape is our counter in? Think about that. That's a circle. So a circle is 360 degrees. Now, if I've already turned 135 degrees through that circle, I can just subtract that angle from my total. So we need to borrow here. That would be 5, 2, and 2. Our angle is 225 degrees. Number 14. A snake's mouth, and this is actually true. A snake's mouth opens to form a 180 degree angle. It's crazy. They can literally they can open their mouth that wide because they don't actually have any jaw bones. It's just a very, very strong batch of muscles right there in their mouth. The snake closes its mouth to form a 60 degree angle. By how many degrees did the angle formed by the snake's mouth change? So they want to know the change, the difference. So the snake's mouth started at 180 degrees. Then he kind of got tired and he closed his mouth a little bit to where it was only open 60 degrees. We want to know how far he closed his mouth. And so we're just going to subtract. 8 minus 6 is 2. Bring down the 1. 120 degrees. Alright, moving on to our practice pages. Page 225 in the practice book. Max, you better go on. Get your nose off my table. Sorry, guys, my puppy's in here with me. Alright, what was I going for? I wanted this. Okay, so page 325. I hope everyone's planning on joining the Zoom meeting this morning at 11. Hopefully some of us or most of us made some kind of instrument. I challenged you guys last week to either make a guitar or like a drum or maybe even like a flute of some sort. I can't wait to show you what my family came up with. We kind of challenged ourselves. We did a few different models of guitars because we had a bunch of craft stuff laying around. Some of it, you'll be able to find pretty easily, probably at your own house. But some of it was just random stuff we had in our yard from something else. Anywho, so the example. Emma turned the knob on a combination lock 117 degrees. How many more degrees does she need to turn the knob to make one full turn? So one full turn would be going all the way around, which is in what shape? A circle. A circle is 360 degrees. And all they did was they took the angle measurement that they knew and subtracted and found out that if they did 243 1-degree turns on this lock, they would end up back in the center of their circle. Alright, Alice is pushing her brother in a swing. The swing is hanging straight down. She pulls the swing back 35 degrees and lets go. The swing moves forward 65 degrees. How many degrees forward from the original straight down position of the swing did the swing move? Good gosh. So, we have our composed angle right here. Alright, that's our large angle, and it was a total of it was a total of 65 degrees. Then she swung, and it went 35 degrees, but how many degrees did it go backwards before coming straight back to the original spot? So what is the difference? We're going to subtract our known angle from our total, so 35 degrees, or 65 degrees minus 35 degrees, that's 5 minus 5 is 0, 6 minus 3 is 3. We have a 30-degree angle. That is our unknown. Unknown equals 30 degrees. And you can always check your work. If you subtracted, you should be able to add your sum and the other angle and get 65. So if we have 35 plus 30, 65. So we must be right. Number 2. A sprinkler in a backyard turns through 180 degrees. The sprinkler has turned 96 degrees so far. How many more degrees will the sprinkler turn through to reach 180? So we have our composed angle, which is a straight angle, 180 degrees. So far, the sprinkler's gone 96 degrees. We want to know how much further it needs to go. And so we're going to find the difference. We're going to say 180 minus our known angle. We're going to have to borrow all the way across. So that becomes a 6 and a 10, 4. Ooh, that didn't work. Or 16. That would have been 18, 17, 7. Excuse me. I got this right. 17 minus 9 would be 8. So it would be an 84-degree angle is our unknown. Alright, almost done, guys. Back of the page. Number 3. A sprinkler turns through 180 degrees every 5 seconds. It turns through 36 degrees every second. Fill in the table below. So, for every second, it turns 36 degrees. So our first turn is going to be 36 degrees. Well, another second goes by. What's that going to be then? Well, 36, remember this is 0, this is 180, alright? So if we're starting 0, this is 36 1-degree turns so far. How much would this be? Well, we add 36. 36 plus 36 would be 72. Don't know where I got that number from. Now, the reason I can't use subtraction is because I have multiple angles I'm going to have to find. And you can't always assume, oh, those angles look similar, so they must be the same. Because they're not going to be. This angle is going to be different then this angle is 36 degrees more than that. So if we keep doing that trend, that pattern, we're going to take 72 and we're going to add another 36 degrees to the 72, which would be 108 degrees. Remember, I already know where it's going to be at 5 seconds because a sprinkler turns 180 degrees every 5 seconds. So this is going to be 180, and I add 108. Let's add 36 to that. That'd be 144. So all I did was I took every second that the angle turned, it turned an additional 36 degrees. So if I had my first angle at 36 degrees, my second angle is going to be 36 degrees more. So I added 36 plus 36, and I got 72. Now I had 72 degrees, and I went 36 more degrees. So I added 36 to 72. I got 108 degrees. So on and so forth. Number 4, write the measure of the unknown angle in the box below. Well, this large angle, you can look at it this way too, is going to be 180 degrees. Here's 48 of those 180 degrees, so we need to find the difference. 180 minus 48, we need to borrow. That's 2, 3, 132 degrees. Number 5 is asking us to do the same thing. Our large composed angle is going to be the same. It's going to be the 180 degrees. But now we're given 2 known angles and 1 unknown angle. So just as we did, it wasn't in the book, it was on this page. Just as we did here, we're going to combine those two. So we're going to say 73 degrees plus 28 degrees. That's 8, 9, 10, 11. Carry the 1, 7, 8, 9, 10. That's 101 degrees. Now, is that saying that this angle is going to be 101 degrees? No. I need to take that 101 degrees and I need to subtract it from my total number of angles. So we have to borrow, that becomes a 9, 7, 79 degrees. Alright, number 6. Use the angle measure below to fill in the boxes in the diagram with the correct angle measures. So, we have this crazy hoopla going on over here. Let's see if we can't figure this out. So, it looks like these two should be relatively easy to figure out. So, this angle measure is going to be 85 plus 30, which is 8, 9, 10, 11, which would be 115. So we use that box. This looks like, so we're talking about this angle now. We have 30 degrees and 75 degrees. So our large angle is 75 degrees, and we're going to have to subtract 30 from it. That'd be 5 and 4. So this would be our 45 degree angle. You see why I subtracted there? I added here because I already knew what my angles were. I wanted to know what my big angle was. Over here, I knew what my big angle was, and I had one measurement of one of my smaller angles, and so I was able to make the difference by subtracting 75 from 30 and finding out that last smaller angle. Now, over here we have this angle. Now, we're trying to find the big angle for this, so we're going to take that 45 degrees and that 65 degrees, and we're going to add it up. 5 plus 5 is 10. Carry the 1. 6, 7, 8, 9, 10, 11. That would be our 110. And then we only have one left. I mean, you can double check by adding all of your large angles together. Or no, you just want to add your individual because you don't want to get confused there. But either way, process of elimination tells us that is at 135 degrees. Alright, day 17 countdown. We are almost done, guys. You know we are on week 7. We only have 3 more weeks of this mess. Who is excited? I am. Okay. Day 17. A grocery store has 330 cans of soda. If there are 10 cans of soda in a box, how many boxes of soda does the grocery store have? So this is going to be a division problem. I know this because I have a lump sum and I need to divide those into a box that has 10. So I'm going to do 10 divided by 330. I know that 10 goes into 33 3 times. 3 times 10 is 30. Bring down the 3, 0. Whoops, not 10 goes into 30 3 times. So our answer is 33 boxes. That's a lot of soda. That's probably how many Mountain Dew boxes I've gone through since this quarantine has started. But you'll be happy to know I'm drinking sweet tea right now instead of Mountain Dew. It's much healthier. I don't know. I put a lot of sugar in my teas too. So, alright, number 2. How many times larger is the value 25,000 than 250? Well, if we think about this in terms of our place value chart, we would have ones, tens, hundreds, thousands, and then 10,000s. 25,000 is right here. 250 is here. Every time we move up a place value, we times by 10. So this would be times 10 times 10, which would end up being 100 times larger. 100 times larger. See how easy that was? This was times 10. This was times 10. 10 times 10 is 100. It was 100 times bigger. Alright, number 3. How many times greater is the value of 4 in 640,700? So we'll just gotta circle that. Then the value of the 4 in 67,040. We can go as far as setting up that same place value chart. So the value of this 4 is going to be 40,000. And the value of this 4 is 40. So we went up, that's 1 place value, 2 place value, 3 place values. Every time we go up a place value, we times by 10. So this is times 10 is 100, times another 10 is 1,000 times greater. Number 4. Match the name of Match the name of each number with its numeric form. Excuse me. I can't even see that very well. Okay, so this first one says 605,000. So that is not 605,000. What's the bottom one? 650,000. That's not it either. So no. This is 600,000. 600. Let's look at it this way. Fine. This is 600,050. Remember, when we see that comma, that's when we name our place. We don't have to do it with our ones, but that first comma we need to remember. That means thousands. So 600,050. So we had 600,050. That matches. Excuse me. And then we had 605,000. So that's 605,000. Oh, there we go. This is 650,000, and we didn't have an option for that, did we? No, we didn't. Okay, so here we go. Number 5. Select all the options with 54,625 written in expanded form. Remember, expanded form can look numerical, like it would be 50,000 plus 4,000 plus 600 plus 20 plus 5. But we can also think of it as this is our 10,000s, this is our thousands, this is our hundreds, this is our tens, and this is our ones. So I have 5 10,000s, 4 thousands, 6 hundreds, 2 tens, and 5 ones. Here it says 5 10,000s, which is true, 46 hundreds, which if we were to combine that would be 4,600, and 25 ones. That would add up. We have 5 10,000s, 4 thousands, 62 hundreds. Could we put that 2 into the hundreds? No, that's going from a smaller place value. We couldn't do that. 50,000s, 4,600s, 20, true. Or nope, that's not true. Not 50,000s. We have 5 10,000s. So I really think that was the only option. No, we could say that. We could say that because that'd be 50,000s blocks. Then we have 50,000s, 40 hundreds. No, that's not going to work. 54,000s, okay. 600s, yep, okay. So we had 3 options here. This one, and this one. And that is a wrap, ladies and gentlemen. That is our math for Monday. Done, over, kaput. Tomorrow we're going to be starting on a new lesson. We're going to be looking at rays and line segments, and my pen's dying. So we did our instructional practice and our countdown. But so be ready with your math journals tomorrow. There is some examples that I would like you to write down tomorrow that would be beneficial to you, that would be helpful. So yeah. And also, remember our Zoom meeting, 11 a.m. If you made or created an instrument this weekend, please share it on our Zoom. Alright guys, you have a great Monday. I hope to see you live in the Zoom class. If I don't see you, hopefully I'll be able to talk to you at some point. We're kind of going back to our normal call schedules this week, where I'm just going to check base. There's a couple of you that I had asked you to do a couple of things for me, and we're going to talk about those over the phone. But it's not really going to be like we did this week, which I'm grateful for, and I know you guys are probably grateful for that as well. Alright, I shall see you guys on YouTube. Bye.